When you think of evolution, what do you think? Maybe monkeys turning into humans, or Darwin's finches from the Galapagos Islands. But have you ever stopped and thought about the molecular beginning of this evolution, the beginning that started all of this visible diversity, the beginning that was put together and substantiated with evidence by a woman who changed science?
Let's look back 1.8 billion years ago when mostly prokaryotic cells lived on Earth. This theory states that a larger archaeal cell engulfed an oxygen non-photosynthetic bacterium. This relationship became mutualistic, as the host provided the engulfed cell with a safe place to live, and the engulfed cell took in oxygen and provided the cell with ATP energy. This was important as the Earth was becoming more aerobic at the time, so the use of the oxygen was very helpful. Another engulfing event happened after that. One of the cells that evolved to have this bacterium turned mitochondria engulfed another bacterium that was photosynthetic. This mutualistic relationship occurred again as the photosynthetic bacterium took in photons from the sun and provided the cell with glucose.
After those two engulfing events, we had the very first idea of what the plant eukaryotic cell is going to look like. A plant with photosynthetic capable chloroplast and a mitochondria capable of cellular respiration. But how do we believe all of this? What evidence substantiated Lynn Margulis's theory? Let's look at the lab. Let's look at the current state of those once bacterium, now chloroplast and mitochondria.
Both chloroplasts and mitochondria have many traits like bacterium we know today. They divide by binary fission. They contain ribosomes with their own DNA sequences. They contain circular DNA molecules, and they have double membranes.
If you think that this theory correctly explains the very beginning of evolution, then you are unlike many people in the 1960s who thoroughly doubted Lynn Margulis and endosymbiosis. After writing her paper, Lynn Margulis sent it out for publication, and it was rejected 15 times. It was finally accepted in 1967, years later, by the Journal of Theoretical Biology, but it was still widely snubbed by the science community. This did not stop Lynn, though. As she explained to Discover magazine, quote, "I do not consider my ideas controversial. I consider them right," end quote. And now this theory is widely accepted, and it's taught to young biologists in schools across the world.